cosine, oh sorry, that should be cosine of x. So, here we go. So phase shift with y equals sine x, cosine x. So phase shift just means if I were to take a trig function, just you don't have to write this down, and I were to take it from here to here, if this is my trig function and I want to move it, okay, and I want to translate it horizontally, okay, how do I do that? You know, if I want to slide it over either left or to the right. And it works very much as if you would graph a parabola. Yes, sir?
Don't you just put like x plus 1 or x minus 1?
Yeah, but it gets a little bit more complicated because you have the frequency in there as well. Okay, so it's like that, except the way they. So let me just explain to you. So if we have, I'm going to just use sine functions. So if I have y equals a sine of b over b, x minus c over b, okay? This thing here is called the phase shift.
Just the C over B.
The c over b. C over b is a phase shift. And the reason it's c over b and not just c is because of this b in here. See, because it's easier to put this in. This is equivalent to saying y equals a sine, when you put this into your calculator, b x minus, what happens when I multiply c over b by b? The b's cancel out, and I get this c over here. You see that? Okay, so this and this are equivalent expressions. It's easier to put it in this form in your calculator, and that's the form that the book uses. Okay, so if you want to find the phase shift, you have to take this letter c and divide by this letter b, which is the frequency, and the frequency is how many cycles does your function go through in 2 pi radians, which is a little bit different than the period. The period is how long does it take, or how many radians does it take to complete one cycle. They're kind of like inverses of each other. Okay, so so it's easier to put this in your calculator, because if you put this in your calculator, then you need to have another set of parentheses out here. That's the way I've always taught it in the past. You see, otherwise it's going to mess you up. So if you put it in your calculator like this, you have to have another set of parentheses. So it's easier to just know that the phase shift is c over b, and just put it in your calculator with one set of parentheses. A couple little formulas which I don't like to use, but I'll tell you what they are, is that bx minus c equals 0. If you solve this for x, this gives you the starting point. Starting point of one period of your function. And if you said bx minus c equals 2 pi, and you solve that for x, then you would get the end point of one period of your cycle. So I'll show you how to do one with using this formula, and then without using the formula, because I find the less formulas that I know, the more it makes me think, and the more I can kind of think about the problem without having to memorize a bunch of formulas. Because sometimes when you're just plugging into formulas, you kind of really don't have as good a conceptual grasp of. Okay, so any case, so say I wanted to graph. I need a different color, don't I? So graph by hand, and you will have to do this on your next quiz. Graph by hand, y equals sine of pi x, whoops, I need parentheses, pi x minus pi over 2. So the first thing, if I were doing this, first thing I would do is find the period. How do I find the period?
2 pi over pi.
2 pi over b. 2 pi, the period is 2 pi over b. Okay, this is b right here. Okay, so the period is 2 pi divided by pi, which is
2.
2, right? Yes, that's the period. 2 pi divided by pi, which is 2. You're okay with that? What?
How'd you get pi? Oh wait, never mind.
So 2 what's?
Wouldn't it be 2 pi on the bottom? No.
No, you just divide, this is b, right? This is b in the formula. So I just divide 2 pi divided by pi, which those cancel out. And I'm left with 2. That's radians, okay? Those are 2 radians, meaning when you label your axis, you just label it 1, 2, 3, 4, 5, 6. You don't have to worry about pi's or degrees or anything like that on your x-axis, okay? Now, the phase shift, the shift is going to be b, excuse me, it's going to be c divided by b. This is c, right here. So I'm going to take pi over 2. I'm going to divide that by pi, which is the same as taking pi over 2 and multiplying by 1 over pi, which is equal to, what's that equal to? 1/2. So the shift is 1/2 of a unit to the right. So this is going to take the sine function and it's going to move it over 1/2 of the unit, 1/2 to the unit to the right. Now if you like that formula, I already forget that formula. Pi bx minus c equals 0. If you like using formulas, you write it down bx, I wanted to write it in red. There we go. Bx minus c equals 0. I know that b is pi, x is x, c is pi over 2 equals 0. I add pi over 2 to both sides. I get pi x equals pi over 2. I divide both sides by pi, and divide by pi, divide by pi, and I get x equals 1/2. And that tells you the starting point, okay?
I thought c was
What?
1/2.
C, in this case, is pi over 2. No, c is this whole number. It's a constant, okay? C is a constant. It's just that number there. So x is 1/2, which I also got this shift is 1/2, right? And so that tells you the start point is at positive 1/2. So now all you have to do is graph this. And when you graph it, it's good to find 5 points. And the 5 points you want to find are we'll just say the start and end point. Start and end, which is easy. The middle, and then the 2, and I'll call it the 2 quarter points. Quarter, that's not how you spell quarter. Quarter, Q-U-A-R-T, here, quarter points. Middle points. And so the start point, oh, let me first make a line like this. Where's this thing going to start? 1/2. Okay, so I'm going to call this 1/2 right there. Now the way I prefer to do it is, rather than figure out the endpoint using that formula, which is kind of confusing, if it's 1/2 and I know that the period is 2, that means that it takes 2 radians to complete 1 cycle. So if I go 2 radians away from 1/2, where's my endpoint? At 2.5. So over here, I could put another point at 2.5. Yes? Easy enough? And since this is a sine function, it's going to start at 0 when this is 0. It's going to end when this is 0. So I have these 2 points already. With a sine function, the middle is also 0. So where is that middle? What's this point right there? No, I know you're going to say that. 1.5. I have to remember how we find the midpoint from geometry? Add together the x's and divide by 2, right? So what's 1/2 plus 2.5?
3 over 2.
Oh, you guys were right. 3 divided by 2 puts you where? 1.5, which is the same, I'll just call it 3/2, okay? Now let's find these quarter point, and so it's going to go through 0 over here. This point, what's halfway between 1/2 and 3 over 2? 1, right? 1/2 plus 3/2 is 4/2. 4/2 is 2. 2 divided by 2 is 1. So this is the point 1, but there it's not going to, and this is the point 2, but there it's not going to go through 0. Since this is a sine function, it's going to go up to what? 1 and down to -1 at those points. So I'm going to put a point here at the quarter point where you have a maximum or a minimum at the other quarter point. And then using that stuff, you could draw a nice smooth curve starting here, going up and down to here and then up. And that is one cycle of your one cycle of this graph. And if you don't believe me, you could check on your calculator. I might ask you to sketch 2 cycles, because this is not just, it's periodic, right? It goes on forever and ever, and kind of goes like this. So just kind of from looking at the graph, what point would this be? Would it be -1/2?
Yeah, it's 1. It's 1 over.
Yeah, it'd be -1/2. You're right. Yep. And so if I asked you to sketch 2 cycles, that's what you would want to do. Okay? Don't sketch 2 bicycles.
That would be a
Even though
problem.
I like bicycles, but that would be, okay? You'll go like this. Anyway. Okay, so let's do another one that's slightly more complicated. What if I said, that's colorful, isn't it? Does that look good? That looks good. So let's do another one. Sketch. That's so sketch. I'm down. I know all the lingo. Okay. 3 cosine. Plus 4 pi. So I would do this one the same way. Both of these aren't that great because they both come out with just plain old radians on the axes, where you'll have other ones where it doesn't have plain old. We'll do it one go in the other direction where it's not just plain old radians. But first thing I would do is find the period. What's the period of this one? 1, right? Because it's 2 pi divided by b, which is 2 pi. So this one takes 1 radian to complete. Now, rather than use that formula, which I think is kind of weird, since this is a plus sign, right, then that means that the shift is going to be negative c, negative 4 pi, over what? 2 pi, which is equal to -2. You can use that formula if you like it, but I think this is easier.
Wait, so why is it a negative?
Because this is a positive. It's kind of like when you know with parabolas, if it's x minus h squared. So if it's plus in there, that means you're moving to the left. Okay? Because the formula says. Okay, so the shift is -2, and this is also. This is the x start point. Yes? X start point. Is there? And so now if I want to graph this, what I would do is, let's kind of do it this way. So it's kind of, because we're going to be looking at 2 to the left, right? And my period is only 1 radian. So I want to start this thing at, say this is the point -2, and I need to complete 1 cycle between -2 and -1. Do you guys understand why that's -1? Because it's going, okay. Now, it's not going to start, so again, this is not a sine function, this is a cosine function. What's the amplitude?
3.
It's not negative 3, it's positive 3 because the amplitude is the absolute value of it. So the negative tells you that instead of starting up here, like a cosine function normally does, where's it going to start?
Like the sun or down.
It's going to start from down and work its way up. Okay? So this point, since this number in front of the cosine is negative 3. Cosine, remember, normally looks like this and goes like that. Okay, starts here. So this one's going to start from down at negative 3 because this is a 3, not a 1. And it's going to end at this point. So now I found my start point and my end point just kind of by finding the period, finding the shift, and using the amplitude and this negative sign. So I found my start and the end point. Where's the midpoint? Midpoint, what's halfway between negative 2 and negative 1? Negative 3 halves, but what's going to happen at that midpoint? It's not going to hit here. Where's it going to go to?
3.
I'm going to have a maximum there at 3. Okay? And if you don't know that, I guess you could plug in here. It's going to get messy, but you could actually figure out by plugging in the value of negative 3 halves. But a cosine function, this is one period. So at halfway, you're either going to have a maximum or a minimum. See that? Relative maximum or minimum. And then the quarter points at that point and that point, that's where you're going to get your zeros. So you're going to get your midpoint is going to be at negative 3 halves, comma, positive 3. And the quarter points are going to be at, I think that's negative 3 halves and negative 2. That's like 6 halves and 8 halves, so they'd be at negative 7 halves. Negative 7 halves, 0. And then the other one is at negative, I believe, 5 halves, right? Because this is 6 halves and that's 6 halves and 4 halves, so halfway between there will be negative 5 halves, comma 0. So there would be your 0 points. And then you could sketch in a nice upside down cosine graph that looks kind of goes through here, up here. Don't make a V, it doesn't make a V, it makes a curve. And then to show that you know that this is cyclical and goes on forever, you should do that again, okay? And again, and again. Get that? Is that hard? What are you looking at over there, Ethan? Nothing.
Actually, on your website.
You're not laughing at things? It looked like you were laughing. Okay. Okay. All right, so now we're going to go the other direction, meaning, so just one more thing, and then I'll be kind of done teaching you for today. So say I have a graph that looks like this. Hey, be quiet, you kid.
It's all the French person.
The French person.
It's all the Frenchie. I'm not even making any noise. Yeah.
So say I'm just going to draw in a curve here. This is a bad curve. But say I say that this goes from negative 4 to 4. And even though it doesn't look like this, let's say that this is centered. And this is negative 3 pi. And this is, this would be 2 pi over here. And let's say, find the, and I say, give the equation, give or find the equation of the graph. I'm going to put one more thing here. 7 pi. This is very much not to scale. As a sine function. Sine function, okay? So let's just assume that this is more symmetrical than it looks like, okay? What's the phase shift?
Negative 3 pi.
I know my website isn't that funny, okay? What's the phase? What's the phase shift, Ethan? How much did I move over from a normal sine function? 3 pi, okay? So, it's shifted over 3 pi, but first I think I want to find the period. What's the period? How long does it take to get from here to complete one complete cycle, if this were to scale? 10 pi, 10 pi, right?
I mean, me too.
Right, up and down. Why? Because from a start to an end. We'll do it both ways. Okay? Yes, works either way. So, shush. 2 pi is, so I know that the period is 10 pi. Does everyone see where that comes from?
Yes.
Okay? And I know that the start point is negative 3 pi. Okay? Yes, ma'am.
Is the start point the phase shift?
The start point, no, because, well, what goes into,
How did you know the phase shift was 3?
it's moved over 3 pi, okay? But,
Isn't that always the starting point though? Because that's what happened.
yeah, but the path, it was already, okay, so let's say that the phase shift is 3, the phase shift is 3 pi divided by, yeah, the phase shift is 3 pi.
Yeah, that's how this is starting.
Okay,
So is the phase shift just what?
is the phase shift just what?
Starting point? On this one?
Yes,
I'm like fitting all of this.
in all of them. Okay, yes, ma'am.
Why isn't the phase shift 2 pi? That tension could also be the starting.
Yeah, we'll get there. Okay, we'll do that in a minute. Okay, so the phase shift, we'll call it negative 3 pi. Okay, if I start here, come on, let's just get through this. Okay, we'll do it both ways. Okay, we all. Okay, we'll do it both ways. So if I want to write this as first I have to find b, which is what actually goes into the equation. So what's b in this case? What's b?
Yeah, that's liquid.
Negative 4. Oh, wait, no, that's a.
B is 2 pi over the period, because I know that the period is 2 pi divided by b, right? So with some algebra, I can show that b is also equal to 2 pi divided by the period. So in this case, I have 2 pi divided by what?
10 pi.
10 pi, which is equal to 1/5, right? So, whoops. So that's not. So so b is 2 pi divided by 10 pi, which is 1/5. So that means when I'm writing this equation, if I want to graph it as a sine function, first of all, since it's starting downhill, what goes in front of there? Negative what? Since it goes down to 4 and up to 4. Negative 4 sine, okay, sine of, and bx, 1/5 x minus 3
Pi.
pi
Wouldn't it be plus 3 pi?
plus 3 pi.
What is the period? Why plus 3 pi? Because it's negative. No, the period's 10 pi. Yeah, it's positive that way. It doesn't go there.
Hold on a second.
Could the phase shift also be -2?
Could the phase shift also be, yes,
Positive.
I could have held it -2. I think I just messed up. 3 pi divided by 1/5 is gonna give me, what's 3 pi? 15 pi?
That's wrong.
Alright, that's what happens when I make up my own problem. Okay, I better pause my video and think about it. Okay, recorder. This is, the phase shift is -3 pi, but except this is written wrong because that's if the 1/5 is outside here, okay? So in order to, the phase shift to be 3 pi, I would have to write this as -4 sine, the 1/5 goes outside, x plus 3 pi, like that, okay? So when I write it in this form, it should, and I distribute this through, distribute through the 1/5, this should actually look like -4 sine of 1/5 x, and when I distribute the 1/5 through, this becomes 3 pi over 5, right? Because if I divide this by 1/5, I get my 3 pi. You see, two different forms, okay? So this, in this form, this tells you exactly what the phase shift is. In this one, you have to divide by b in order to figure out the phase shift. I could have, and yes, this could have also been -2 pi, which would have given you exactly the same function. I could have written it as -4 is negative because it'd be shifted. So I could have written this as 1/5 x minus 2 pi, okay? Or 2 pi over 5, or 1/5 x minus 2 pi over 5. And both of those, if you wrap them, would have given you exactly the same thing. Okay? Okay, I hope that helps.